Hello guys, in this video I'll be explaining EG231, that is Statics and Dynamics chapter 3 practice problem. Okay, so under chapter 3 we have this question. Okay, the question is to say the tower crane. Okay, this tower crane is used to hoist a 2 megagram rod upward a constant velocity. Okay, the 1.5 uh 1.5 the 1.5 wrong BD. Okay, the 1.5, so this is B and this is D. Okay, there is a 1.5 wrong BD and 0.5 megagram uh, BC. Okay, and 6 megagram counterweight, having the center of mass of G1, G2 and G3 respectively. Okay, so let's set our solutions here. Okay, so G1 represent this. Okay, so therefore our G1 is equal to 1.5 megagram. Okay, therefore our G2 is equal to 0.5 megagram. Okay, our G3 is equal to 6 megagram, as simple as that. Okay, and as you can see, there is also, look this question, this party, the tower crane is used to hoist a 2 megagram rod upward the constant velocity. So there is also a weight here. Okay, and this weight or rod of 2 megagram. Okay, for this one. Okay, yeah, we also have the weight of the load. Okay, we also have the weight of the load, and this is the load. Okay, exactly. Okay, so therefore determine the resultant moments produced determine the resultant moment produced by the rod. Okay, and the weight of the tower crane about point A and what about point B. Okay, so the moment at A is equal to moment at B. Why? Because they are in same line. Okay, moments at A and moments at B, they produce the same moment. Why? Because they are in the what? They are in the same line. Okay, that is the reason they are producing the same moments. Okay, yeah. So we can start moment to the force produced by B. Okay, so as I said, the moment is the product of force and the perpendicular what? Distance. Okay, so we're going to find the force for this one. Okay, force for this one, or rather the weight. Okay, the weight for this one, that one and that one. Okay, so we start with the sorry, we start with the G1. Okay, sorry. Okay, so I'm going to start with G1. Okay, so I'm going to start with the G1 and okay. Okay, so I'm going to start with G1. Okay, we are going to convert it into weights, or rather force. Okay, weight is equal to ma, mass times acceleration due to gravity. Uh, therefore acceleration due to gravity is equal to 9.81 meter per second squared. Okay, and then mass is measured in what? Kilogram. Okay, so for G1, okay, G1 is 1.5 megagram. So we're going to convert it to kilogram hour. Okay, so 1 megagram is equal to, so this is megagram, is equal to uh, 1 times 10 to the power 6 gram. Okay, therefore 1.5 megagram is equal to what? So let's do the calculation here. Let's do the what? The calculation here. Okay, so 1.5 times 1 exponential 6 is going to give us 1 5 0 0 0 0 I mean 0 1 2 3 4 5 0 0 1 2 3 4 5. Okay, gram. Okay, but for this case we're going to convert it to kilogram. How? So we're going to turn it 1 2 3, so it's going to be 1500 kilo, sorry, kilogram. Okay, that is our weight C for G1. Okay, therefore weight is equal to mg, which is 1500 times 9.81. Okay, 1500 times 9.81. Okay, so it's going to give us 14715 newton, which is equal to 14.715 kilo newton. Okay, so this is our first weight. Okay, that's our thing, our first weight. Okay, okay, therefore one is equal to 14.715 kilo newton. Okay, now we go to weight 2. We go to what? To weight 2. Okay, let me label this. Okay, go to weight 2. Okay, now we go to weight 3. Weight 2, same procedure. We're going to convert for weight 2. We're going to convert 0.5 megagram to what? Kilogram, same procedure. So it's going to be like this. So it's going to be like this. 1 megagram is equal to 1 times 10 to the power 6 gram. Okay, therefore 0.5 megagram is equal to x. Okay, therefore x is equal to, cancel this, 1 exponential 6 times 0.5, so it's going to give you 50000 1 2 3 4 5 1 2 3 4 5 gram. Now we're going to convert it to kilogram. 1 2 3, so it's going to be 500 kg. 500 what? Kg. Therefore weight is equal to mg, mass times acceleration due to gravity. It's going to be 500 times 9.81. Okay, therefore 500 times 9.81 is going to give us 4905 newton, which is equal to 4.91 kilo newton. Okay, this is our weight 2. Okay, you can plug it there. Weight 2 is equal to 4.91 kilo newton, as simple as that. Okay, so I just want to show you the whole method of how you can go about this question. Okay, uh, now we go to a third stuff. Okay, we go to a third stuff, which is weight 3 equal to 6 megagram. 1 megagram is equal to 1 times 10 to the power 6 gram. Therefore, 6 megagram is equal to x. X is equal to 1 exponential 6 times 6. Okay, so it's going to give you something like 0 measures 1 2 3 4 5 6 2 3 4 5 6 gram. Now going to convert it to kilogram, so it's going to be like this 1 2 3. It's going to be like this 0 kg. Okay, therefore we can find the weight for 3. Weight is equal to mg. It is equal to 600 times 9.81. Okay, it's going to give us 600 times 9.81. It's going to give us 58860 gram, Newton, which is going to be 1 2 3 58.86 kilonewton. Okay, so that's our weight 3. Okay, for weight 3 is going to be 58.86 kilonewton. Okay, 58.83 kilowatts in kilonewton. Okay, now the last one is the weight of the load. As you can see, we have been given to say this load is 2 megagram. This one, okay, is 2 megawatts in gram. Okay, so weight of the load, let us find the weight of the load. Therefore, 2 megagram, we're going to convert it 1 megagram or 2, megagram, 1 times 10 to the power 6 gram. Now for this one, it's going to be this. Let's do the calculations. 1 exponential 6 times 2 is going to give us 20000. That means just 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, gram. Now convert it to kilogram because mass is measured in kg. So it's going to be 1 2 3. Okay, so it's going to be 200 kg. Therefore, weight of the load is equal to mass times acceleration due to gravity. It is equal to 2000 times 9.81. Okay, it is equal to 200 times 9.81. Okay, this is going to give us 19620 Newton, which is equal to 19.62 kilonewton. Okay, so which is equal to 19.62 kilonewton. Okay, so we are done converting this thing to forces. Okay, our next thing is for us to find the moment of this thing, same forces that we have found. Okay, the moment of these same forces that we have found about point B. Okay, about point what? B. Okay, therefore moment of the force is the product of force times what? Perpendicular what? Distance. Okay, therefore our moment is equal to, so you can start with N. Okay, so as you can see, these forces G3 and G2, when we apply the forces here, they are going anti-clockwise, which is positive, but this one are going what? Clockwise, which is negative. So these two forces are going to carry negative, but this one are going to carry positive. You get? Yeah. So let me love this, create some spaces. Okay, you can start with any force you want. Okay. Therefore, moment of the force about B is the product of force times perpendicular distance. So this is our point B. Okay, so you can start with G3. Okay, so weight 3 here is a product of force times perpendicular distance. So our force is here, then perpendicular distance from point B. So perpendicular distance is going to be like this, 7.5. Okay, so it's going with 3 is going to be 58.86 times perpendicular distance, which is 7.5. Okay, that is it. Let's see. Sorry. Okay. All right. Let me have it. It's from here. Use 58.86 times perpendicular distance, which is 7.5. Okay. Now we go to G2. G2 is at 10. G2 is at that point. Okay. And its perpendicular distance is the distance from where to where B is. Okay. And this distance is 4 meter. So it's going to be plus G2. The weight of G2 is going to be 4.91 times perpendicular distance, which is 4. Okay, this is moment of the force about point B. Okay, uh, and I say this ones will carry negative. So B negative G1. What is our G1? That is 14.715 times perpendicular distance, which is 9.5. 9.5. Now this one is what we are calling weight of the load, which is 19.6 negative 19.62 times perpendicular distance, which is 12.5. I think you know the reason why I'm putting negative. It is because these forces are going what clockwise, and clockwise carry a negative, but clockwise carries a what a positive. Okay, so we need to do the calculations here. We need to do the what the calculations there. Okay. Um, so when you do the calculations, the final answer is going to give you 76.2775 kilonewton meter. As simple as that. So this is how we go about this question. Okay. So as an engineer, you should not fear this question. You just see the diagram, you start fearing. No. As an engineer, you have to analyze the question, analyze it. Okay. So guys, this is the end of this video. See you in the next video and have a nice study session. Okay.